Hello everyone, my name is Shambabu and today I would like to present about my IoT final project Smart HVAC control system using ESP32, MQTT, Verilog FSM and Node. For the project, I only ran on the simulation and I didn't have a chance to run on any hardware. So in this video, I will only show my simulation. This is my Wokwi simulator and I use DHT22, ESP32 with 3 LED and a resistor. So the green LED is for the system, blue LED is for the cooler, and red LED is for the heater. So when I run the Wokwi simulation, it's connected to the Wi-Fi and MQTT broker is published, all the data is published. So now when we look at it, our temperature is 28.5 degree and the set point is 26 degree. So cooler will be on. If we change to temperature like 18 degree, so it's less than our set point, so cooler will be off and heater will be on. For this project, I also try implement with the Node. So I will show the Node dashboard. This is my Node topic and the UI I written. I subscribe to the MQTT topic and connected to the Node dashboard. So I will show my Node dashboard now. This is my Node dashboard. We can see the live temperature and humidity now as the Wokwi simulator, and also we can control the system manually. Like heat is on now, but when we click cold, it's changed to cold and the mood will be manual. So when we want to open the heater on with heat, the mood is stay manual and action is heat. If we want to change back to auto, click auto. Auto mode resume. So the set point is 26 degree and the temperature now is 18.1 degree. So it's a cold temperature, so heater will be on. When we change to like 25 degree, 27 degree is greater than our set point 26 degree. So let me change. So cooler will be on and temperatures. The set point here is control our ideal temperature. If we change our ideal temperature to the 27, it's the same as the current temperature, so nothing will be on and the state will be idle. It's 26, 27, 27, so nothing will be on and the state is idle. If we set our set point into the 28, the temperature is less than the 28, so heater will be on. Oh, it didn't change. Okay, 28.5 and the heater will be on. This is how we can control our Smart HVAC system, and also we can change the set point. We can control the system manually like auto and manual mode. Also we can close the system off the system if we don't want to use and just control outside manually. If we click close, system will be closed. Also I try implement with the Node Verilog simulator I run here. So in the auto mode, if the temperature is too cold, expect heat, so heat will be 1. If the temperature is too hot, expect cold, so cold will be 1. If we change back to comfort, nothing will be on because the temperature and the set point are almost the same. In the manual mode, if we force cold, auto is 0 but cold will be on. If we force heat, heat will be on, and if we turn off, auto 0 and every state will be 0. If we change back to more auto mode and then the temperature and the set point is same, auto mode will be on, but the cooler and heater nothing will be on. So this is my project about the Smart HVAC control system using ESP32, MQTT, Verilog FSM and Node. Thank you for listening and thank you for watching the video.